Welcome to the deep dive. Today, we're digging into artificial intelligence. It's something that's becoming, well, part of everything, isn't it? From our phones to maybe even, big medical advances.
It really is. We see AI doing amazing things, but how it gets to its answers, that often feels like a total mystery.
Like a black box.
Exactly like a black box. Imagine you put something on one side, something else pops out the other. But what happens in the middle is hidden. That's often the feeling with complex AI.
Right. And this black box thing, it's not just like intellectual curiosity, is it? This lack of clarity, it makes it harder to trust AI, harder to use it responsibly.
Especially in really critical areas, yeah. Think healthcare, finance, places where getting it wrong has, major consequences.
Okay, so that's our mission for this deep dive then, to try and understand what's inside that box.
Precisely. We want to look at explainable AI, XAI for short. Think of it as AI that sort of shows its work. It's really the key to unlocking how these systems operate.
And we're going to try and keep it clear, right? Not get bogged down in like super technical jargon.
Absolutely. The goal is to break it down piece by piece so you get a real sense of what's actually going on inside these powerful tools.
Okay, so let's start right there. What is black box AI, really?
Okay, so at its core, a black box AI is usually a system, often one using complex machine learning like deep learning, where the internal steps are just not obvious.
You see the data going in, you see the result coming out.
But the journey between those 2 points, that's the murky part. Deep learning uses these things called neural networks, kind of like layers of decision points, all interconnected. And these networks have tons of adjustable parameters. The AI tweaks these parameters as it learns from, well, vast amounts of data.
So it's not just that it's complicated, it's genuinely hard to trace the logic. What makes it so opaque?
Well, a few things.
Yeah.
First, the algorithms themselves, the basic instructions, can be incredibly complex. Then, the AI learns these really subtle, intricate relationships from huge data sets, things we might not even notice.
Okay.
And the structure itself, these deep neural networks with many, many layers, adds complexity. It's actually fascinating. Even the creators might not fully grasp every single influence on the final output.
Wow. So they build it, but it sort of takes on a life of its own, in a way. Its internal logic becomes a bit mysterious even to them.
In a sense, yes. I mean, consider some models have millions, maybe even billions of these parameters.
Billions?
Yeah, and they're all interacting in these complex, nonlinear ways. That creates a level of obscurity that makes understanding the internal logic extremely challenging.
Okay, so we've got this powerful tech, but it's often a mystery inside. Why should you, listening right now, really care about this opacity? Why does it matter day to day?
Well, it matters a lot, actually, across several key areas. First, as we mentioned, it just erodes trust.
Right. Hard to trust what you don't understand.
Exactly, especially when the stakes are high. Healthcare decisions, financial applications, even law enforcement tools. You need to know why an AI reached a conclusion, not just what it concluded.
Makes total sense. If an AI suggests a medical diagnosis, the doctor needs to understand the reasoning, right?
Absolutely. And beyond just trust, this opacity makes it really difficult to spot and fix biases.
Bias in the data.
Bias in the training data, yeah. If the AI learns from biased information, it can perpetuate, even amplify, those biases, unfair outcomes. And the black box nature makes it incredibly hard to figure out where the bias is coming from and how to correct it.
So the AI could be unfair, but we wouldn't easily know why or how to fix it.
Precisely. Then there's the whole question of accountability.
Who's responsible when it goes wrong?
Exactly. When the inner workings are hidden, tracing back an error is, well, it's a nightmare. Was it the algorithm, the data, a weird interaction? This lack of clarity makes it hard to learn from mistakes.
Yeah, that sounds really messy. What else?
Hidden flaws are another big one. Security vulnerabilities. The complexity can hide weaknesses that malicious actors could potentially exploit.
Okay, that's worrying.
And then there's regulation. In many sectors, like finance, there are rules requiring explainable decisions.
So opaque AI could actually clash with legal requirements.
It certainly can. Plus, without understanding how an AI works, it's tough to know its limits. Where is it strong? Where might it fail?
What are its blind spots?
Exactly. That means deploying it safely in the real world, where things are unpredictable, quite risky. All these technical points, they tie directly into bigger ethical concerns, fairness, equity, trust, responsibility.
Okay, so the black box is definitely a significant problem. What's the answer then? How do we start to peek inside.
That's where explainable AI, XAI, comes into the picture. Remember, AI that explains itself. It's a whole field dedicated to making these AI decision processes more transparent, more understandable to humans.
So the goal is literally shining a light inside that box.
That's the core idea. XAI aims to give us insights into how models arrive at conclusions, which factors were most important, and the reasoning behind specific outputs.
And by doing that, you build trust, right, and make it easier to spot problems.
Exactly. Build trust, spot and fix bias, improve accountability. It's becoming crucial.
And we're seeing it pop up in more fields now.
Absolutely.
Wow.
There's a growing demand for AI we can actually understand.
Yeah.
Think about medical research, or we said healthcare diagnoses, treatment plans.
Right.
But really, anywhere you need confidence in an AI's decision, XAI is becoming essential. And interestingly, the foundational goals set out a few years back weren't just about making models interpretable without losing accuracy, but also really focusing on the user, making sure the explanation actually helps people understand and trust the system.
So it's not just explanations for AI experts, it's for the end users, the doctors, the loan officers, maybe even the patients.
That's the aim, making it meaningful for those affected by the decisions.
Okay, so how is this actually done? What are the tools in the XAI toolkit?
Well, there's quite a diverse set of techniques, actually. Each offers a slightly different window into the black box. One category is feature importance methods.
Okay, what do they do?
They basically try to tell you which input features, which pieces of information the model weighed most heavily in its decision. Gives you a kind of high-level overview of the AI's priorities.
So for that loan example, it might say income and credit score were key factors.
Exactly. Then you have something called LIME, which stands for Local Interpretable Model Agnostic Explanations.
Lime, like the fruit.
Yeah. The key idea with LIME is focusing on individual predictions. It works by creating a simpler, understandable model that mimics the complex AI's behavior just for that one specific instance.
So instead of explaining the whole complex beast, Lime gives you a simple explanation for one specific decision, like why this loan was denied.
Precisely. It makes understanding individual cases much easier. Then there's SHA, Shapley added explanations.
Okay, SHA.
This one uses concepts from game theory, actually. It calculates a specific contribution value for each feature for a particular prediction. So it tells you how much each input pushed the final prediction up or down.
So Lime gives a local approximation. SHA tries to precisely quantify each feature's contribution to that one outcome.
You got it. And in deep learning, especially with images or text, attention mechanisms are really useful.
Attention. How does that work?
They basically let us visualize what parts of the input data the model focused on most. So for an image, it might highlight the specific pixels or regions that were critical for classifying it. For text, it might highlight the keywords.
That sounds incredibly useful for seeing what the AI is looking at.
It really is. And one more main type, rule extraction techniques. These try to distill the complex logic the AI learned into a set of simpler, human-readable if-then rules.
Like, if income is below X and credit score is below Y, then deny loan.
Something like that, yes, though often a bit more complex. And beyond these, there are others, things like saliency maps, anchors, partial dependence plots, counterfactual explanations, which look at what-if scenarios. It's a growing toolkit.
It definitely sounds like the field's moving fast. Any recent breakthroughs that are particularly exciting?
Oh, absolutely. XAI is evolving rapidly. There's a big push towards making explanations more sophisticated, but also more user-centric.
More useful to actual people.
Exactly. One trend is trying to map the AI's internal representations the way it thinks onto concepts that humans readily understand.
So translating the AI's internal language into ours.
Sort of. We're also seeing work on interactive explanation systems, where you can almost have a dialogue with the AI to understand its reasoning better.
Wow, like ask follow-up questions. Why did you focus on that part of the image?
Potentially, yes. Another really interesting area is concept-based XAI. Instead of explaining things in terms of raw data points, it uses higher-level concepts, like explaining a medical diagnosis based on recognized symptoms rather than pixel values.
That sounds much more intuitive.
It often is. And we're seeing large language models, the tech behind things like ChatGPT, being used to translate the technical outputs from XAI methods into plain natural language.
That could be huge for accessibility, taking the complex SAP values, for example, and turning them into a simple sentence.
Exactly. Then there's something called mechanistic interpretability. This is a really deep dive, trying to dissect neural networks neuron by neuron almost, to understand precisely how computations happen.
Really getting into the nuts and bolts.
Pretty much. Plus, there's ongoing work on inherently interpretable models, models designed to be transparent from the ground up, and hybrid approaches combining simple interpretable models with more complex ones. You just have to look at the major AI conferences now. XAI research is everywhere. It's a really hot area.
So these tools and breakthroughs sound great in theory, but are they actually being used? Where is XAI making a difference in the real world?
Yes, definitely. We're seeing applications pop up where trust and clarity are paramount. Let's take healthcare first.
Okay, critical area.
Absolutely. The need for explainability there is, well, obvious. XAI helps clinicians understand why an AI tool is suggesting a certain diagnosis or treatment. That's fundamental for building trust.
You wouldn't just blindly accept an AI's diagnosis.
No way. So, for instance, XAI can highlight the specific patterns in a chest X-ray that led the AI to suspect pneumonia.
Ah, pointing to the evidence.
Exactly. Or it can explain predictions about patient outcomes based on historical data, giving doctors understandable reasons. And for personalized medicine, it can justify why a specific drug is recommended based on the patient's history, genetics, potential interactions.
Makes sense.
We're seeing techniques like Lyme and S-shape used for things like diabetes diagnosis and combined methods for breast cancer detection, trying to get both accuracy and clarity. The potential to reduce errors and improve care is huge, but transparency is the key enabler.
Oh, healthcare makes perfect sense. What about finance? Another area with big consequences and lots of rules.
Definitely. Finance is under intense regulatory pressure for transparency and accountability, so XAI is vital. It's being used in credit scoring.
To explain loan decisions.
Yes, to reveal the factors driving an approval or denial. In fraud detection, it can pinpoint what about a transaction looks suspicious. Maybe an unusual location or amount.
Okay.
And things like algorithmic trading or risk assessment, XAI can offer transparency into the strategies being used or the factors indicating risk. Again, you see methods like S-shape and Lyme being applied. It's crucial for regulatory compliance, think Fair Credit Reporting Act, and just for maintaining customer trust.
So if an AI flags your transaction as fraud, XAI could tell the bank why it looks suspicious, not just that it did.
That's the goal, yes. Then there's law enforcement.
Ah, now this is a sensitive one, right? Using AI for crime prediction or suspect ID.
Extremely sensitive. AI offers potential tools here: crime pattern analysis, forensic help, identification. But the ethical concerns are massive. XAI is seen as crucial for transparency, fairness, and accountability. Well, it can help demystify the complex algorithms, providing investigators with interpretable insights. There's research into explainable image recognition for forensics, for example. And for facial recognition, explainability is really non-negotiable, given the potential for error and bias.
So understanding how the AI matched a face is critical.
Absolutely. XAI is vital for trying to mitigate biases in things like predictive policing or risk assessments used in sentencing, ensuring due process. Organizations like NIST are actually developing XAI tools specifically for law enforcement contexts. But the key message always has to be responsible implementation, focusing on fairness, accountability, and privacy.
It's clear XAI offers a lot, but it can't be perfect, right?
Yeah.
What are the main challenges or limitations we're still grappling with?
No, it's definitely not perfect. There are significant hurdles. One of the biggest is often called the accuracy-interpretability trade-off. Meaning often the simpler models that are easy to understand might not be quite as accurate as the really complex, powerful black boxes.
You might have to sacrifice some performance for clarity.
Sometimes, yes. Finding that optimal balance is tricky and it really depends on the context. What's more important for this specific application, peak accuracy or clear understanding?
Right, the priorities might differ.
Exactly. Another challenge is the subjectivity of explanation. What counts as a good explanation? It really varies.
Depends on who you're explaining it to.
Precisely. An explanation that satisfies a data scientist might be meaningless to a doctor or a customer. Tailoring explanations effectively and consistently is hard.
Makes sense. A good explanation needs to match the audience.
Then there are plain technical hurdles. Generating these explanations, especially for huge models trained on massive data sets, can be computationally expensive. It can slow things down.
So it might not scale well in some real-world application.
That could be a barrier, yeah. Also, evaluating explanations is tough. We have clear metrics for accuracy, right? Like, did it get the right answer? But how do you objectively measure the quality of an explanation? Is it helpful? Is it faithful to the model? There's no single ground truth. And current methods are often fragmented or rely on subjective user ratings.
So we know if the AI is right, but it's harder to know if its explanation why it's right is actually good.
You've got it. And finally, we need to watch out for explainability pitfalls.
Pitfalls, like what?
Like users developing misplaced trust just because an explanation exists, even if it's superficial. Or overestimating the AI's capabilities because it seems understandable. Or even, more cynically, using explanations to kind of fair-wash biased models, making them seem fair when they're not.
Using explanations to mislead.
It's a risk. Careful design is needed to avoid creating false confidence or enabling misuse.
These are really crucial points. It's not just about making it explainable, but doing it well and responsibly. Now, you mentioned regulations earlier. What's the general picture looking like, say, in the U.S.? Is the law demanding explainability?
It's evolving. That's the best word. There isn't one big, comprehensive federal AI law yet, but we're seeing a patchwork emerge at state and federal levels.
Okay. Any examples?
Sure. California have its AI Transparency Act focusing on disclosure when content is AI-generated and about training data. Colorado passed a broader law aiming at consumer protection, safety, and tackling algorithmic discrimination. Utah has a law about liability if generative AI is misused without disclosure.
So different states are taking slightly different angles.
Exactly. And importantly, attorneys general in several states have made it clear that AI use still has to comply with existing laws. Consumer protection, anti-discrimination, data privacy laws still apply.
So AI doesn't get a free pass from current rules.
Not at all. There are also ongoing bills being debated federally and in other states, many touching on transparency. And NIST, the National Institute of Standards and Technology, has published principles for explainable AI, offering guidance for trustworthy systems. So the trend is definitely toward recognizing the need for transparency.
It sounds like the legal and regulatory side is trying hard to keep pace with the tech. For the developers and researchers actually building this stuff, are there practical tools readily available to implement XAI?
Oh, absolutely. The open source community has been incredibly important here. There are numerous Python libraries that make implementing XAI techniques much easier.
Like which ones?
Well, we mentioned Essay and Lime. Those have very popular libraries. There's also EII5, which tries to make explanations simple. Interpret ML from Microsoft, which has a broad range of tools, including inherently interpretable models.
Okay.
AIX360 from IBM, Alibi Explain, Captain for PyTorch models, Omnix AI, which is quite comprehensive, others like PyCakes AI, ExplainX, OpenXAI, the list goes on. Each has its strengths, focusing on different techniques or model types.
Wow, so there's no shortage of tools for people to try. What's the general process look like if you want to actually use one of these?
It usually starts with defining your goal. Why do you need explainability here? Is it for debugging, trust building, fairness checks, regulatory compliance?
Okay, know your objective.
Then choose the right technique considering your model type, your data, and crucially, your audience for the explanation. It's generally best practice to integrate XAI early in the development lifecycle, not just tack it on at the end.
Makes sense. Plan for it.
Then present the explanations clearly. Visualizations often help, or translating technical outputs into natural language, as we discussed. And finally, evaluate its effectiveness. Does it meet the goal? And you have to consider practicalities, performance trade-offs, consistency, privacy implications of explanations, and any relevant regulations. But yes, these tools empower developers to make AI much more transparent.
It really sounds like explainability is becoming a more integrated part of AI development. So looking forward then, what are the big trends? Where is XAI headed?
The future looks really dynamic. The demand for transparency and accountability, driven by ethics and regulation, isn't going away. That will continue to push the field. We're seeing intense research into novel approaches, things like more sophisticated concept-based explanations, and incorporating causal reasoning, trying to understand not just correlation, but actual cause and effect in the AI's decisions.
Moving beyond what to why.
Exactly. There's also a huge focus on human-AI collaboration, making explanations truly user-centric, interactive, maybe even incorporating human feedback into the explanation process.
So the human and AI work together to understand.
That's the idea. We're also seeing XAI methods being adapted for the newest AI paradigms, like generative AI, trying to understand how models like DAL or GPT come up with their outputs in reinforcement learning, where understanding an agent's choices is vital for safety.
Applying XAI to the cutting edge.
And there's a push towards standardizing methods and creating more integrated, user-friendly toolboxes. Organizations like DARPA continue to fund ambitious projects aiming for a deeper mutual understanding between humans and AI. Some researchers are even exploring ideas from cognitive science, like theory of mind.
Theory of mind, like understanding intentions.
Kind of, yeah. Equipping AI with the ability to model human mental states to provide better explanations. The overall trajectory is towards AI that's not just more powerful, but hopefully more transparent, understandable, and better aligned with our values.
It feels like we're genuinely moving away from the impenetrable black box towards something more like a glass box, maybe.
That's certainly the ambition. The black box problem, it definitely poses real challenges: trust, responsibility, fairness. But explainable AI offers a concrete path forward.
We've seen the techniques, the breakthroughs, the real-world applications in critical areas like healthcare, finance, law enforcement.
And while challenges remain the trade-offs, the subjectivity, evaluation, the momentum is clearly there. The research, the regulatory focus, the open source tools, they're all pushing towards greater transparency.
It really feels essential for building a future where AI isn't just powerful, but also trustworthy.
Absolutely. It's about moving from inscrutable systems to ones we can understand, scrutinize, and ultimately rely on more safely.
So for everyone listening, as you think about this, consider what increasingly transparent AI might mean in your own work, or just your daily life. As we get better at seeing inside these systems, what new possibilities open up? What new ethical questions or practical hurdles might we face? Definitely something to mull over. Thanks for joining us for this deep dive.
This is DigitView.